I do want to go over this and make sure we're all okay. A lot of y'all, your translation side of your classwork yesterday looked excellent. The reflection side looked rough. Reflections should not be hard. With reflections, you want to use your rules though. So how many of y'all, like, do y'all want me to show you how to graph it and also the ordered pairs? Okay. So I'm going to show y'all how to graph this one again. So remember, if we reflect over the x-axis, that would be, thank you, sir. I'll give it back to you before I go over it. If we reflect over the x-axis, that would be this part, correct? So to graph it, you want to count your distance from the mirror line and go the opposite way because it's a reflection. So D is 2 away from the x-axis. So if I count 2 down, this is where D prime would be. Is everybody okay with that? Okay. So B is 1, 2, 3, 4 away. So 1, 2, 3, 4. This would be B prime. And then G prime is 5 away. So if you go 5 down, there's G prime. Oh my goodness. This is hard. Clicking and dragging. Huh? Yes. Yeah. That's why I don't like doing it. I like using the overhead better. Like graphing reflections, y'all should be okay with because we've already done reflections with functions. You should be able to find that mirror line and then count 2 the opposite way or 3 the opposite way. Okay, we'll do some of those. So y'all really quick, look also how you could have done this, how you can check yourself. What is our rule when we flip over the x-axis? So first of all, when I flip over the x-axis, make sure your phones and stuff are up and you're with me. When I flip over the x-axis, what kind of flip is it? If you flip over x, vertical. Everybody, if x-axis is here and you're in the top, that's going to reflect down. If you're already in the bottom quadrants, that's going to reflect up. It's a vertical reflection, which means what's going to change? What coordinate? The y value. Did y'all not understand the rules yesterday? When we went over them, y'all seemed okay. I'm genuinely asking. I think y'all think I don't check your homework. When I check your homework, I actually look at what you put, and like over half of you missed the reflection problems, which is not good. Did we understand the rules from yesterday, or did we just forget them on the homework? As no one answers. You forgot. You understand them. You understand them. Okay. All right. I don't know why half of you missed it then. My online people, are y'all good with reflections? Oh my God. Hello. Don't make me. Beatty's great. Your homework looked good, Beatty. I ain't talking to you. I like talking to you though, because you actually answer. Keyshawn, Riley, Chris, Tyler, y'all good?
Yeah, I'm good.
Okay, Riley's good. All right, y'all. It's so sad. I love talking to myself. Y'all, answer. All right. Another way you could have checked it, take each point. So D is at -2, 2. Do y'all agree? Make the y the opposite. So instead of the y being at +2, D prime should be at -2. Very good. Instead of B being at +4, B prime is going to be at -4. And I got to go figure out the x value. 1, 2, 3, 4, -5. That's a 4. I hate doing this. All right, instead of G being at +5, where's it going to be once we flip it vertically? -5. I'm spending a lot of time on this because so many of you missed it. Are we okay with the reflections? Okay. If you are not, I need you to come to tutoring today or ask me questions now. All right, for number 2, I don't feel like I should have to do that one. So number 2, that capital T means it was translated. They're all transformed. The word for a slide is translation. So we moved it where? Very good. Right 2 down 6. So if it goes right 2, did y'all add 2 to all those X's? If it went down 6, did y'all subtract 6 from all the Y's? Okay, so did y'all get, I'm going to say it out loud to make sure you're listening. For J, did y'all get -1, -11? Yeah? Okay, for L, did y'all get -1, -9? For E, did you get 2, -11? All right. Most of you did really well with translations. The whole reason I made this warm up was for the reflections, if you couldn't tell, because there's more of those up here. All right, I gotta move my Zoom, baby, so y'all can see this next one. Clear all drawings. Okay, number 3. So people said they needed help with this one. There is not a rule. Yeah, I brought my charger. Sorry. There's not a rule when you're flipping over an X equals line or a Y equals line, because it depends where the mirror line is. It's not an axis, so it's not going to stay the same the whole time. Okay. So if you're flipping over X equals -1, I showed y'all yesterday how to graph that. So X equals -1 would be right here. Do y'all agree? Yes. Okay. How far away from the mirror line is Z? 1. So you go 1 the opposite way, and there is Z prime. How far away from the mirror line is X? 3. So then you go 1, 2, 3 the opposite way, and there's X prime. And then it looks like U is 4 away. 1, 2, 3, 4. Yep. So 1, 2, 3, 4 the opposite way. And there's U prime. There's got to be a better way to draw these lines. Let's see. That looks much better, doesn't it, L'Oreal? She's like, yes, Lord, don't try to draw any more lines. Does that help if we're reflecting over not an axis? If it's a vertical or horizontal line, y'all, it can be anywhere. So there's not a set rule for that. You're going to have to count and actually graph it to find the ordered pairs, okay? All right, I'm going to keep going, my online babies. Are y'all good?
Yeah.
Thank you, Riley, for answering extra credit. All right, not 24, 4. It looks like we translated left 4 up 2. So did y'all subtract 4 from all the X's and add 2 to all the Y's? Okay, so listen, did you get -9, 0? Then -8, 3. Then -7, 2. And then -6, -2. Awesome. All right, this one is reflected over the y-axis. So instead of graphing it, because I feel like y'all are okay with graphing, let's think about it. The y-axis is the vertical one. So everybody look at my arm right now. If I'm flipping over the vertical axis, what kind of flips are these? Horizontal, because they're going left or right. So if it's a horizontal flip, what is going to change in my ordered pair? The X's are going to flip because it's horizontal. So T is at 1, 1. That means T prime should be at -1, 1, right? Which does look right if you wanted to go graph it. X is at 5, -1. So what would X prime be at? -5, 1. Very good, Carter. You're just switching your X value, changing it to the opposite. I prime would be at what? -1. I'm sorry. Thank you. I prime? -2. My online people, I love y'all. Y'all did so good, and like lately y'all been real quiet. I need y'all participating so I know where you're at, okay? So I don't know how to help y'all if I don't hear you. -2 what? -4. Good job. Do we feel better about reflections? Okay, let's review our other 2 rules. I don't feel like I need to do number 6, so I'm not going to worry about it because most of y'all did okay on those. Our rules, we already did X and Y axis. What's your rule when you have a reflection over the line Y equals X? Yeah, you flip X and Y. Very good. Because this literally says the Y value is going to become the X. So the X will become the Y. And if you watched the video yesterday, that's when we do a reflection over this diagonal line, right? Okay, what's the other kind of reflection we can have? There's one more. What?
Y equals -X.
Woo, extra credit beating. Good job, girl. Y equals -X. I heard you too. It took y'all a second though. What do you do, Beatty, when it's Y equals -X? Do you remember?
Both of them turn negative.
And you flip them, right?
Yeah.
Good job. X equals -Y. No, when you're graphing lines, remember it should say Y equals something. Yep, good question. Lines, remember, should say Y equals MX plus B. So the reason the X's and Y's flip is because it's over that diagonal again. So they're going to switch places. But this time they're both going to be negative because this line has a negative slope. So I said that yesterday. A lot of y'all left the Zoom when that question was asked though. So does that make sense? So for number 1, it asks you to write a rule to describe each reflection. If you draw a mirror line right in between these shapes, it goes through 2 on the x-axis. So that would be reflected over x equals 2. That's a vertical line, which means it should say x equals. Thank you. That was me. I'm not even on the line tool. For number 2, what does it look like we cut these through like the middle where they can be reflected? Where would the mirror line pass through? Good. -1. They said -1 on the y-axis. So that would be a reflection. So technically you should put capital R. Y equals -1. For number 3, if you drew a mirror line through the middle so that these could be reflected over it, it was reflected over Y equals 3. Good. Jaden, you did good, babe. Number 4, most of you got right. That was a reflection over the y-axis. Please don't just put RY. I don't know what that means. Like, did you mean a y equals line? Did you mean the y-axis? Like, put y-axis, okay? Number 5, did y'all get it's reflected over x equals 1? Okay. And then what about number 6? Yeah, it looks like it's flipped kind of diagonally, right? So that's reflected over the line y equals x. Good job. Do we feel better about reflections? I feel like we should be fine with it. I feel like it's one of the easier things we've done. But like I said, a lot of y'all struggled on the homework. So ask me questions now if you don't feel okay with reflections. So since we're having tech issues, your table of contents, we are on page 48. And today we're going to be talking about triangle transformations. Me spelling is not going to work, so I'm going to abbreviate. Can you do a text box? Oh my God, y'all are so smart. Extra credit, you two. Oh, geniuses. For real, extra credit, because I don't know how I haven't figured that out before, because reading is hard, I guess. Triangle transformations, and what we're talking about today are dilations. Geniuses. Sean, make sure you have this, babe, because I won't have a copy for you to get later. Like, there's no way for me to save this. All right, so what's up, Sudie? I do. I have tutoring today. It's Thursday. Tutoring is 3:15 to 4. All right, triangle transformations, dilations. The transformations we did yesterday were what? What did we do yesterday? Reflections and translations, not a transformation. That's what all of them are, translations. So we did slides and flips, right? Okay, when you shift or slide something, or when you flip something, does it stay the same size and shape? Yes. For extra credit, who remembers what that is called? What's it called when something keeps its size and shape? Rigid. Extra credit. Good job, Henry. It's rigid. Those are rigid. When you dilate something, so yesterday we talked about getting your eyes dilated. What happens when you dilate your eyes? They get bigger, right? When you dilate something, you're making it bigger or smaller in size, okay? But when we make it bigger or smaller, obviously the size is changing, so that's non-rigid, right? What do you think is special about how we make it bigger or smaller? Do you think like we make one side bigger and the other side of the shape stays the same? Do you think we make the whole thing bigger and make it bigger by an equal number? Yeah. Okay, let's think back to Unit 5A. We did congruent triangles, which meant the triangles were the exact same. So think about it. I want to make sure you're listening. This is a question on your test. Congruent triangles are rigid because they are the same shape and the same size. Everything's the same with their equal, right? So congruent triangles look the exact same. That's like taking it and flipping it or sliding it. Similar triangles. When we did similar triangles last unit, what was special about the sides? They said they were different. I need somebody who's going to be more specific. In similar triangles, what was special about the sides? Yeah, y'all, love you. We have all established the sizes were different. How were they different? What was special about them? You're on the right track. Everybody else is looking at me like they already threw similar triangles out their brain, which is not good because you got to do those in math 3. Oh, extra credit. And you were getting there. He was getting there. He was trying. They were proportional. Every single side would have the same proportion, right? That is what a dilation is. I'm going to take the shape and either make it bigger on every single point by the same number or make it smaller by the same number. Okay? So dilations, let's write this down because y'all are struggling to remember. Dilations are non-rigid. Why am I writing instead of typing? Because I'm stupid. Let's switch to a text box. And what non-rigid means is they are the same shape, but they're a different what? Size. Very good. So in example, when we did similar triangles in Unit 5A. I actually kind of like this typing thing. I could have been doing this all semester. Same shape, different size. All right, y'all. So write down a definition for dilation. A dilation is an enlargement or reduction of a pre-image. So now I'm going to ask y'all a couple of questions. When we did our proportion, or proportions, I should say, when we did similar triangles, and they all changed by the same proportion, who remembers what I called that proportion? You can look back in your notes because I know you got it. When we did proportions for similar triangles, and let's say the proportion was supposed to be 1/2 for all of them, right? What did I call 1/2? There's a name for it. A ratio, a common ratio, very good, or you can look. Who are you talking to, Haley? You could say it. You should all know it. Thank you, Carter. Extra credit. A scale factor, y'all. What is wrong? Listen, I'm yelling at y'all too. I'm yelling at everybody. What is wrong with y'all? Trigonometry. This ain't trig. This is transformations. Okay, you can't take stuff and throw it out of your brain when we're done with the unit. Because if y'all get to Math 3 next year and you embarrass me, I will come in there and embarrass you. Because I've taught my heart and soul out. And I love when kids go to Math 3 talking about something. Yeah, my Math 2 teacher didn't teach this. Yes, they did. Y'all don't be remembering. Because y'all memorize stuff for tests and throw it out. That is not good. You got to retain stuff, okay? Especially vocabulary. That's like the most important thing about math. If you know what the words mean, you can usually figure out the problem. Viti, where are you at, girl? You're supposed to be my vocab queen. She said, I'm not answering. I feel embarrassed. Changes by a common ratio or a scale factor, okay? So let's talk about our scale factor. If our scale factor, and y'all, a lot of times for a scale factor, they use the letter K. So I'm gonna go ahead and put that. Did I spell scale wrong? Thank you. I put an extra F in there. The F was towards y'all for not remembering the things I teach you. My dad used to go like this and say, read between the lines when we were little and we didn't understand it. And now that I'm older, I'm like, that was clever. If our scale factor is a fraction, so think about it. If everything is changing by a fractional amount, do you think we're making the shape bigger or smaller? Smaller. If you multiply something by fraction, aren't you making it less? Like if I have 4 markers and I multiply them by 1/2, that means I'm cutting them in half, right? So now there's only 2 in each group. You make it smaller. So if our scale factor K is less than 1, then the dilation is a reduction. Is everybody okay with that? Okay. So what do you think that means if our scale factor is bigger than 1? Good. What do we call that? Then the dilation is an enlargement. Very good. So if our scale factor is less than 1, we're reducing the size of the shape. You cut something in half, you make it smaller. Let's say the scale factor, I put an F in there again, Lord Jesus. The scale factor is bigger than 1, like 2. That means you're doubling the size of the shape, right? Very good. There's a reason, I'm gonna keep it real with you, I forgot, because it's been a while since I taught this. So we can look it up after this. That was a good question. He asked why they used a K. I know there's a reason because I've looked it up before, but I honestly forgot. So we'll look it up after this because I'm curious too. All right, so if our scale factor K is less than 1, it's a reduction. Bigger than 1, it's an enlargement. Only other thing I need to teach you, and then we're doing examples because I really feel like y'all will be fine with these. Only other thing we need to talk about, and I'm going to put it just over here so that nobody has to change the page. Y'all put it underneath yours. If you cannot tell, this is important, that's why I put a star. So you may want to box it, highlight it, circle it, do something. If you cannot tell what the scale factor is from the coordinates, you can use this formula right here. So you can do the image number divided by, let's see if I can figure out how to do divided by. Wow, smart. No, because somebody's going to mess that up. I'm going to actually give you a formula. You can do the image number divided by the pre-image number. So if you want to figure out how it changed, whatever the image is at, divide that by where it started, and that can give you your scale factor. Now, I'm going to keep it hot with you. I don't use that a lot. And I'll tell y'all why as soon as you're done writing. Can y'all listen while you write? I feel like there's awkward silence. No? Okay, I'll wait a second. So if our triangle starts out at like 2, 3, and then it ends up at 4, 6, what did I do to each of those numbers? Thank you. Good God, y'all are not auditory. Y'all can't hear something and like tell me the answer. Here you go, kiddies. If a point is at 2, 3, and now it ends up at 4, 6, and it's a dilation because the size isn't the same anymore, what did I do to it? Multiplied by 2. So your scale factor would be 2, which means it's an enlargement. Very good. I don't normally need to do image divided by pre-image because I can look at this and say, oh, it multiplied by 2. Easy peasy. If it's weird numbers, like let me show you an example. Look down here. If we have like 5, 1, and then it ends up, is everybody watching? Yes? Fantastic. Why did I choose 5? Because I'm not going to know what that is. Let's do this one. If you have 3, 1, and then it ends up at, I don't know, 2. That's not going to work, but it's okay. It's because I'm trying to think of it in my head. It's really hard to see how we like change that, isn't it? So this is one where I would use the formula and do the image number divided by the pre-image number. So what is 2 divided by 3? 2/3. Thank you. That wasn't a hard question. 2 divided by 3 is 2/3. So we are shrinking it or reducing it by 2/3. Does that make sense? Okay. I feel like we need to do more examples because some of them are looking at me like I just taught them Spanish. Gloria, what's wrong, boo? You good? Are you good? Okay, you looked confused. All right. So I'm going to switch my screen. My people at home, do y'all have all the notes? You don't have to write down these examples. I was just showing you stuff. I've got an example sheet for you. Y'all okay with the notes?
Yeah.
Okay. Some of y'all might have liked that better. I don't know. All right. So I'm going to pause for a second so I can pull this worksheet up. Okay. So I'm just going to do a couple of examples for 1 through 4. I feel like I don't need to do these, but I'm going to talk about one just in case. Number 2, if the scale factor is 1/3, is that an enlargement or a reduction? It is a reduction. Very good. That's easy, right? Like I shouldn't have to do any more of this. Sean, are you good with K being 1/3? That's a reduction. So 5, he asked about number 3. That's a great question. Everybody look at number 3. 5/4, is that bigger than 1? Then you're making it larger. It doesn't have to be a whole number. Like I can multiply something by 1.5 and that's making it bigger because it's bigger than 1, okay? What if, and this is a hypothetical question, what if they told you the scale factor was 1? It wouldn't change. So is that a dilation? It's not, because that would be a, what's the R word? A rigid, thank you, a rigid transformation. So the scale factor, if they did try to say it was 1, or if they said like, what would a dilation with a scale factor of 1 look like? That's not a dilation, okay? So that's like a slide or a flip, not enlarging or reducing. Very good. All right, let's look at number 6. So it says, determine whether the dilation from figure A to figure B is a reduction or an enlargement. So people at home, if you were not able to print this, that's totally okay. If you want to draw it in your notes, you can. If not, just pay attention. So determine whether the dilation from A to B is a reduction or enlargement. So look at A. If A turns into B, did we make it bigger or smaller? Bigger, so that is an enlargement. Very good. Enlargement. Okay. So now what I want y'all to look at, it says determine the scale factor. So everybody look. This A point right here, does everybody agree was at 0, 2? I want you to find the same point now, but on B. Do y'all agree it's at 1, 2, 3, 4, 5? Okay. Most of us cannot look at 2 and say, what do I multiply 2 by to get to 5? I said most of us because some of you might be able to. What do you multiply 2 by to get 5? Exactly. So they're struggling a little bit, and that's okay. If you're really good at mental math and you said, oh, that's 2.5, fantastic. You don't need to use the formula. If you're, don't you write that down, because none of y'all look at that and tell me 2.5. You did? I didn't hear you. You mumbled it, which means you weren't very confident. So listen, if you can't look at how the numbers change, like what they were multiplied by, take your image and divide it by your pre-image. So where did we end up? What was our image value? 5. You ended up at 5. Divide that by the pre-image. That'll tell you what you multiplied by. So our pre-image started at, if you do 5 divided by 2 in a calculator, that's 2.5. So to figure out what you multiply by, this is the important part right here, because this is a test question, because y'all always mess this up. So listen, to find your scale factor, if you're trying to figure out what you multiply by, take where you ended up and work backwards, which means to divide. Isn't dividing the opposite of multiplication? So if you take where you ended up and divide where you started, it'll tell you what you multiplied by. Okay? Image over pre-image. Where you end up over where you started. Okay? All right, let's do another one of those just to make sure y'all are good. Did that make sense to y'all at home?
Yeah.
Awesome. Okay, so let's do another one. Y'all look at A and B on this one. Extra credit, what kind of shapes are these? Oh, extra credit, Henry. A pentagon. Y'all learned that in middle school, right? Y'all gonna make me sad. A pentagon, 5 sides. What's it called when it has 6 sides? A hexagon. What's it called when it has 7? A hectagon, H-E-C-T-A. 8 is octagon, 9 is nonagon, 10 is decagon. You need to know those for math 3, but that's okay. You'll learn them. We can look that up too. All right, y'all look at number 8. Is A to B an enlargement or a reduction? An enlargement, very good. Enlargement again. From A to B, number 8, that is an enlargement. Now we want to find out what K is. So everybody look, I'm just going to pick a point. It does not matter which one you pick, but I would make sure it's one that you can like visibly tell what it is. Honestly, all of these kind of suck. I'm going to go for this one right here. I say they suck because they're not a whole number. But that's okay. What does it look like that X value is at? 1.5. Yeah, I would say it's at 1.5, and the Y value, since it's sitting on the axis, is just 0, right? Yeah. Okay, that's your pre-image. Where did the image end up? At 2. So listen, and I can't even do this one in my head. So if you can, I'm gonna be really proud of you. We need to figure out what we multiply 1.5 by to end up at 2. I'm gonna keep it real with you. I don't know. So what's the way you can figure that out? The image, which was 2, where you ended up, over the pre-image where you started. What is 2 divided by 1.5? Yeah, I need y'all to help me. I don't know. What did you say? 1.33333, which is 4/3. I do know that. You didn't earlier. You said a half. Somebody said a half. 4/3. So we're taking A, multiplying it by 4/3, and that's how we're ending up at B. If you wanted to check yourself, y'all look, 1.5, I'm gonna do this in green. 1.5 is just 3/2. So if you multiply 3/2 by 4/3, I'm just showing you how you could check yourself. So everybody look up here. What happens with the 3's? They do cancel. So 4 divided by 2 is 2. Do y'all feel like you can look at a graph and tell me the scale factor? If you can't look at it and see, then you can use the formula I showed you. Does that make sense? Okay. I hope we had that. Did anybody not have it? Find the scale factor. Let's do one of these just to make sure y'all are good. And then I think after this example, y'all really should be good to go work. Draw a dilation. Y'all should be able to do that, I think. Maybe we should do one just in case. All right, let's do 10 right here. Point A is a vertex. Point R is the image after the dilation. Find the scale factor. What's the formula I taught you to find a scale factor? Image over pre-image. Very good. Image over pre-image. So look at this. What's the image value? You can pick X or Y. Doesn't matter because it should be equal, because it should be starts with a P. Proportion. Very good. So it doesn't matter. You can pick X or Y. It should be proportional. Y'all want me to do X's or Y's? Okay, so does everybody agree the X of the image is what? Ooh, the image. Point R is the image. Good. 6 over, what's the pre-image X? 9. What is 6/9 reduced to? So we multiplied by 2/3. That would be your scale factor. Good. It should seem easy after we did similar triangles. That's where it comes from. No, this is the last day of notes ever. I'm not. Can someone tell them? I just said this yesterday. They don't be listening. I'm not teaching tomorrow. You're working on your exam review / test review tomorrow. I ain't teaching Tuesday either. It is an exam review. I'm taking it for a quiz grade. Because some of y'all don't be remembering stuff I taught you 3 weeks ago. Children. What'd you say? I'm doing one more and then we're done. Forever. I feel like I'm in the Sandlot. All right, everybody look at 16 and then I'm done. Notes are done for forever. After 16, don't leave yet, my virtual people. But really quick too, y'all make sure that on Friday, tomorrow, you do join Zoom and ask me questions on that exam review / study guide this time, since y'all did not do well last time. Okay. And then I would join Zoom on Tuesday as well, because that's your test review day. All right, 16, K equals 1/4. 1/4 is the scale factor. So am I reducing this triangle or enlarging this triangle? Reducing it by 1/4. So everybody look, pick a point. We're actually gonna have to do all of them because it says draw the dilation. So we're gonna have to graph it. What is this point at right here? 0, 4, not 4, 0, 0, 4. It goes left to right, none, up 4. So if I take 0, 4 and I cut that into a fourth, think about it. What is 4 times, not dividing? This is the scale factor. I already told you the scale factor. You multiply to find the image. 4 times a fourth is just 1. So guess what? Your image point would be at 0, 1. This would be A prime. People at home, are y'all okay with that one?
Yeah.
Okay, so it looks like B is at 4, -4. Multiply each of those by a fourth, and Sean said it should be at 1, -1. So this would be B prime. Not hard. I don't like, this is the easiest unit we do all year, and that's usually why I save it for the end, because y'all are tired, I'm tired, everybody's tired. And then C, do y'all agree, is at -4, -4? Okay, so multiply everything by a fourth. Where would C prime be? -1, -1. And this would be your dilated triangle. So it looks just like the big one. They're the same shape, but they're different sizes, which makes them, starts with a S, they are proportional, similar. There you go, good job. All right, so listen, the worksheet, you are finishing it. However, I was nice and you only have to do the odd ones. It's like 14 problems and you have almost 20 minutes. You're welcome, because I could have made you do the whole thing like the other teachers. Just the odd ones. My people at home, the ones that say to graph, I do want you to graph them, okay? Do y'all have any questions for me on dilations or about notes in general? Oh my God, I just poked myself in the eye. Your notebook check will open tomorrow and it's due next Thursday. Any other questions? Comments, concerns?